First of all, can I say thank you to the President of the 18th Congress for inviting me to help you start the work of the Congress by considering the science and economics of climate change. What I'm going to do in the half an hour or so I have available to me is to deal with three topics. Could I have the next slide, please? Thank you. First of all, to think about the science. What are the reasons for concern about climate change? Then to move on to the combination of science and economics. How do the impacts of climate change affect us? And then to move through to think about economics. How much should emitters of greenhouse gases pay for the impacts that their pollution causes? Quite a lot to deal with in half an hour, so let's move on. We've heard from the President of the Republic just a few minutes ago just how serious Portugal thinks that climate change is as an issue. And we have other statements from other leaders of scientific communities and political communities around the world. Lord May is president of the UK's oldest scientific society, and he said that climate change can be likened in its destructive scale to the effects of using weapons of mass destruction. A very serious issue. And just 1 week ago, less than 1 week ago, President-elect of the United States, Barack Obama, in his acceptance speech, in just 13 words, put climate change there up in the very top group of concerns for himself, his presidency, and the world. The fact that he is inheriting 2 wars, a planet in peril, and the worst financial crisis in a century. So what lies behind these statements? The science of climate change and the greenhouse effect is actually very well known. It's based not on modern science, it's based on 19th century physics. That's when it was first identified as an effect. And all that's happening is that as the sun heats the earth, the rays of the sun come and hit the earth, and some are reflected back out as longer wavelength radiation. And the greenhouse effect gases stop some of those long wavelength radiation rays getting back out into space and reflect them back down to the Earth again. And that just means that in order for the Earth to be in balance with the heat coming in and the heat going out, as it must be in the long run, the Earth has to be at a higher temperature for those two things to balance. There's no dispute about the greenhouse effect. It's verified, for instance, by data from the planets. Mars, Venus, Mercury, and the Earth. Mercury is the closest planet to the Sun, as we see on the top, and yet its temperature at 179 degrees centigrade is lower than that of Venus, which is further away from the Sun, whose temperature is 420 degrees centigrade. And the reason for this is that Venus has an atmosphere almost entirely composed of greenhouse gases. We also know from calculations done many years ago, that the Earth's surface would be about 33 degrees centigrade cooler and frozen over completely if we did not have a greenhouse effect in the atmosphere. So why are we worried about this? Well, that's the natural greenhouse effect. That's the effect that's been there for millennia and is not what we're concerned about when we talk about man-made greenhouse effect. If we look back over the last 500,000 years, we see that the main greenhouse gas that we're concerned about, carbon dioxide, the concentration of that in the atmosphere has fluctuated within fairly well-defined bounds. It's been through a low down to about 180 parts per million on the blue line, and up to a high of about 280 parts per million. And for the last 500,000 years, the concentration of this main greenhouse gas has been between those two limits. When it's been towards the top end of the range at 280 parts per million, we've had a climate very much like today's and the 20th centuries. When it's been at the low part at 180 parts per million, the climate has been an ice age, with ice sheets covering northern Europe down as far as the north of France and the Netherlands, 2 kilometers thick of ice. So the difference between a carbon dioxide concentration of 180 parts per million and 280 parts per million is the difference between an ice age and the rather pleasant climate that we've had in the 20th century. Now, the Intergovernmental Panel on Climate Change has looked at what we might expect to see happen to the concentrations of climate change over the next century. And you see various projections there for what might happen to the concentration of this gas if we don't make attempts to deal with the problem. The differences are because there are different assumptions about how the world will grow, how it will organize itself, what the population will be, and so forth. But you can see that the vast majority of these scenarios of the IPCC have an increasing concentration of carbon dioxide from 380 parts per million, which is roughly where it is today, up to 5, 6, 7, maybe even 8 or 900 parts per million. And if we superimpose that on the previous slide, which showed the concentration over the last 500,000 years or so, essentially we have an instantaneous rise far outside the range that the world has been used to coping with in the past. None of this is controversial, by the way. No climate change skeptic would disagree with those values for carbon dioxide concentrations. What the skeptics have to say really is, okay, I know that the difference between 180 parts per million and 280 parts per million is the difference between an ice age and today's pleasant climate, but I'm not worried about it going up to 500, 700, 800, 900 parts per million. I really don't think that's going to cause us a problem. Well, that doesn't seem like a very prudent way of viewing the issue to me. And indeed, in the IPCC, they don't take that view. The leading scientists around